Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the final product. The final product is octahydronaphthalene, a bicyclic compound with 2 fused 6-membered rings and 1 double bond at the ring junction, also called octalin or delta-1, 9-2-octalin. It has the molecular formula C10H16 with 1 double bond. More precisely, the structure shown is bicyclo 4.4.0 DC1,6Na, a decalin with 1 double bond between the bridgehead carbons. Step 2. Work backwards from B to A. B is produced from A by treatment with Lyell-4 reduction, and B then undergoes acid-catalyzed dehydration, H+, heat, to give the bicyclic alkene. The dehydration implies B is an alcohol. So B is a bicyclic alcohol whose dehydration gives the fused 6-6 bicyclic alkene. Step 3. Identify B. For the product to be a fused bicyclic 6-6 ring system, decalin skeleton with a double bond, B must be a spiro or fused bicyclic alcohol that rearranges dehydrates. A spiro alcohol where one ring is cyclopentane and the other is cyclohexane, spiro, 4.5, decon 1-ol, can undergo ring expansion dehydration via carbocation rearrangement. Protonation of the OH gives a tertiary carbocation at the spirocarbon. Ring expansion of the cyclopentane ring by a 1,2 carbon shift converts the 5-membered ring into a 6-membered ring, giving a bicyclic 6-6 fused carbocation, which then loses a proton to give the observed decalin alkene. Step 4. Identify A. Lyell-4 reduces a ketone to an alcohol. So A must be the ketone corresponding to B. If B is spiro, 4.5, decon 1-ol, cyclohexane spiro joined to cyclopentanol, then A is spiro, 4.5, decon 1-1, the ketone, cyclopentanone ring spiro fused to cyclohexane. This matches option D, a cyclohexane ring spiro fused at C1 of a cyclopentanone. Step 5. Verify the rearrangement. Spiro, 4.5, decon 1-ol, from reduction of spiro, 4.5, decon 1-1, under acidic conditions, the tertiary spiro carbocation forms, the cyclopentane C to C bond migrates, ring expansion, to give a bicyclo, 4.4.0, decalin, carbocation elimination gives delta-1, 9-octalin, matching the shown product. Step 6. Eliminate other options. A. 1-acetylcyclohexane is a monocyclic substrate and cannot directly give a bicyclic product without additional ring formation. B. Spiro, 4.4, nonan 1-1 has 2 cyclopentane rings. Ring expansion would give a 5+6 fused system, but the carbon count, 9 carbons total, is insufficient for decalin, 10 carbons. C. Has a cyclobutane ring. Ring expansion from cyclobutane under these conditions and carbon count do not match the decalin skeleton. Therefore, the correct answer is D. Therefore, the correct answer is option D.